This week I used a programming pattern at work that we haven't covered on the channel before. I had to refactor a class that had a long series of if conditions for handling data in a particular sequence, but the sequence needed to be reordered in some scenarios. A chain of responsibility lets you break down all these logical blocks into their own handlers so that you can execute them in any sequence that you want, and you can take a huge monolithic block of logic and make it very modular. Each handler executes its own logic and then chains into the next one. Let's look at a few ways this can help us in gamedev. Let's have a look at how we can use this pattern to help us break down updating quests in a quest system. This current system here has one entry point, update quest. It's trying to make updates to the quests in this system by going through a series of deeply nested if and if-else statements. Even though it's bare bones right now, as development in this area continues, this is going to turn into an absolute nightmare. I mean, even just looking at it right now, it's hard to parse at a glance what it's even doing. If I page down to the bottom of the file, you can see there's a small beginnings of a serializable quest object, and there's a few enums for defining quest state and quest events. What we're going to do today is refactor this into the chain of responsibility programming pattern. This is a pattern that lets you pass requests along a chain of handlers. Each handler in the chain is going to decide to either process the request or pass it on to the next handler in the chain. This is surprisingly easy to implement. Let's start with an abstract base class. We'll call it quest message base. For now, I'm just going to pass around an ID that represents a quest. In the future, we can add more details, but for now, let's just have a start quest message, let's have a complete quest message, and let's have one in case a quest actually fails. Now let's have an interface that will actually represent the links in our chain. I'm going to call that iQuestProcessor. We're going to want to be able to set the next link in the chain from this one, and each link in the chain will be able to do some processing based on a message that comes in and a collection of quests that we're going to pass in, similar to what exists right now in the code. Most of our processors are going to share some common functionality, so let's have an abstract base class here that implements the interface. Each of these will need a reference to the next link in the chain. Our setNext method can take in a reference to the next link in the chain, set it, and return it so that we can actually chain these methods together. Then we'll have our process method in the base class that's just going to call the next link in the chain and run its process method. We're going to make this virtual so that we can have our own functionality in each of the concrete versions. So let's implement one of these. What do we want to do when we're starting a quest? Well, let's override that process method and debug something out to the log so we know that we're doing something here in this processor. Next, we can verify that the message that came in is something this processor actually wants to handle, and we can also make sure that the quest ID that was passed in is something that actually exists in our quest dictionary. If it does, let's put that out into a new variable quest. Then we can get started handling any logic we want to perform here. So a really simple example might be we could just say if the quest state is not started, then let's just change it to be in progress. Log something out to the console, and at this point we could just return. Effectively, calling return here is going to break our chain. However, if we wanted to continue processing, we just have to call the process method in the base class, which is going to run the process method on the next link in the chain. So our logic here is going to try to handle the start quest message here. If it can, good, we're done. If not, continue on to the next link in the chain. For our next link, let's have a complete quest processor. So here, it's going to be almost identical. We need to have a process method. We'll debug something out again so that we know we're here. And again, let's verify that we want to handle this kind of message and make sure that the quest exists. Then let's do whatever logic we need to do. So here, just as a simple example, we'll say if it's in progress, let's say that it's completed. Let's change its state, debug something, and return. We'll end the chain here. If we can't handle it, again, we'll call base.process and keep the chain going. Let's make one more just for our demo here, and that'll be in case we need to fail a quest for some reason. So here, again, overriding process, we'll debug something out. We'll have almost identical logic. Make sure we can handle it. If so, we'll do whatever we need to do. So here, we'll just change its state again. Once the state's changed, we can debug something if necessary. We can also return because we're finished. But of course, we can add even more links to the chain. So let's make sure that if we can't handle it here, we just try to continue on. Now, I'm sure some of you have started to notice the repetitive nature of these different processors. At this point, I would start to consider using a generic processor. So this way we could just pass in any T message and handle it. Now, this is beyond the scope of what I want to talk about in this video, but it's just some food for thought. Now that we've got our chain set up, let's go and replace all that terrible code. Here, I'm just going to select everything and wipe out this entire class. Let's just start from scratch because I don't even want to use a list for these quests. We might as well replace that with a dictionary. Then, of course, we're going to need a reference to our chain. In the awake method, we can set the first link of the chain will be our start quest processor. Then we can just link up every other link in the chain with the set next method. Ironically, we can chain these methods together. We can add some helper methods here, of course. We might want one to actually register a quest into the dictionary. And of course, we need a method to replicate all those nested if-else statements, which is we need an update quest method that takes in a message and runs the chain. Just pass in the message and our quest dictionary. And that's it, an incredible improvement in readability and modularity. Why don't we create a very simple mono behavior just so that we can fire this up in Unity and see how it works? We can make a mono behavior called quest demo. Here we can have a reference to the quest manager and we can create and register a new quest with its own ID and name. Then let's just send in some messages to the quest manager. Let's start with a start quest message where we just pass in the ID. Then we could update the quest with a complete quest message. And then we could also try a fail quest message, but at this point the quest would already be completed, so it shouldn't actually do anything. Let's try it out. I've already added the scripts and references to this example game object, so I'm just going to hit play. Right away, we should see quite a bit of messaging out in the console, starting with the start quest processor. Here we can see that it starts the chain at the start quest processor and actually starts the quest. The next one goes through the first two processors before it gets handled, and it actually completes the quest. The last one goes through all three processors but isn't handled by any of them. That's because the quest is already complete, so there's nothing to fail. Now in this example, we've looked at a chain where each of the steps is expected to be able to handle it and then stop processing. Let's look at an example where we might want to do some processing and then keep moving down the chain. This next class is a debugger that's meant to essentially debug messages out to the console or out to files, or debug different information or serialize objects and debug them. It's very simple, but you can see already that as it develops, it's going to get fairly complex. Some messages might want to output something to the console. Others might want to save to a file and to the console. There's also a guard clause right at the beginning of the processing to handle any nulls. So why don't we set up an abstract base class that will handle kind of debug messages that we want to use. We'll have a public property to represent the message and a basic constructor that'll just take that in and set it. So the simplest concrete version of this, of course, would just take in a message and pass it to the base class, and that would be it. But we might want a more complex one that actually saves some state. So we could have the name of the state and some object data that we want to serialize. There we could pass those two into the constructor and pass some kind of message for a title. This title can be passed into the base class as our message and used in future processing. Then in our constructor here, we'll just set those two objects. So now we have two kinds of debug messages we want to use, general and save state. Let's make an iDebug processor interface. Just like the other one, we're going to need to be able to set the next link in the chain and also do some processing on the messages that come in. Let's do an abstract base class here where we store the next link in the chain. In the set next method, let's set the value of next and return it. And if there's any problems, we'll throw a argument null exception. Here in the base class, our process method will simply process the next link in the chain. So let's start making some concrete processors. First of all, let's have that guard clause represented by a null check processor. So here our process method is simply going to check if the message is null or the message's message property is null. If so, we're going to log an error out to the console and return, and this will stop the chain. If we get past this guard clause, let's just call base.process and continue down the chain. Now, the next step in our chain might just be to output something to the console. So here in our process method, we can just debug.log whatever the message was that came in. Now here's where it gets different than our previous example. Instead of returning here, I want to give all the other processors in the chain a chance to do additional processing on this message. So no return statement, we just process the next link. Now, maybe the next thing could be that we want to log out to a file, whatever's going on. So here we could have a string for the path to where we want to save things. We could pass that in through the constructor and set it. During the process method, what we can do is have a try catch. We can start with the try block. Here we'll try to write out to the file. We can record the time and our message as well. If we have to catch, well, let's log something out to the console to let us know that we can't write to the log file. Then, again, instead of returning, let's just continue down the chain. Of course, we can make as many links in the chain as we want, but let's just make one more that would actually save the state of some kind of object that we want to preserve. So here in process, let's just check and make sure it's the kind of message that we want to deal with. If so, let's create a new file where we want to output whatever this is that we're storing. In a try catch block, we can try to create JSON out of that object data. We'll write all this out to a file, and let's also debug something just for our own edification. If we have to catch it, of course, we can log a message to ourselves saying that we couldn't do it. And then again, instead of returning, let's just continue down the chain. Now let's go back to our debug toolkit class where we have this growing bit of nonsense. I'm going to select everything here and wipe it out. Now we can store a reference to our chain, and in the awake method, we can assemble the chain. Let's start with our null check guard clause, and then let's chain on everything else. So here, actually, I'll move everything onto new lines so it's a little bit easier to read. With our chain in place, we just need a method that we could call. So we could just call it log, and we pass in some kind of message that we want. All we have to do here is call the chain's process method, and everything will be handled. Let's create a new mono behavior debug demo. In the start method here, we can just start logging some messages, really. So we might just want some general ones that are just messages, or we might want to actually save some state about the player. We could pass in some object that represents that player's state at a specific point in time. We can do this by passing in a serializable struct or class that represents some bit of data. Then, just for interest's sake, let's test out that guard clause as well. Now, these look a little bit verbose, but of course you can overload the log method to make these quite a bit more concise. Let's jump back into Unity and make sure this is working. I've already added the components to this game object, so I'm just going to hit play, and right away we should see some output in the console here for every single time we've tried to debug something. So the first time, it's just telling us that the application started, and of course that got logged out to our file using the file processor as well. If I open up Notepad here, you can see that we have one file here where it output that serialized player data. We've got another one here where it's just shows all the different times that I pressed play while recording this video, which is quite a few now. But essentially every time the chain has reached the file processor, it's made an entry into this log file. Now, some of you may be wondering what inspired this video and this dive into chain of responsibility. And the reason that I used this in the real world was to actually handle the processing of real-time messages that were dynamically assembling a database query. So messages would come in with information about which fields to filter and which conditions to apply, and additional constraints or sorting instructions. The chain allowed each processor to focus on a single responsibility, and so it added its own piece of logic to the query before passing the message along. And this modular approach made it easy to extend the system by adding new processors. But of course, the biggest advantage was it eliminated hundreds of lines of nested if-else statements that were impossible to decipher or to even to test. But as you can see, it's a very useful pattern for all kinds of other things. Let me know in the comments below what you think of the chain of responsibility pattern, or what kind of interesting things you've used it for. And of course, feel free to join us on Discord if you're interested in discussing this kind of topic or anything else that's game dev related. New videos every Sunday, so hit like and subscribe if you're interested in more content like this. I'll throw another video up on the screen, maybe the broker chain pattern if you haven't watched that one yet. Maybe I'll see you there.